Welcome to V Guide. This is the continuation of quick revision of laws of motion. In this video, I am discussing few important topics of laws of motion, that is the continuation of the previous topic, and some numericals based on this. See, the first page I have given the diagram of constrained motion. This is the case in which the body placed on a floor. So this is floor and here we are keeping a body of mass m. So in this case the body cannot move in the vertical direction. If you apply the force, the body can move only horizontal direction. That's what I wrote, y equal to 0. It means vertical displacement 0, vertical velocity 0, vertical acceleration is 0. Ay indicates the vertical. Okay, vertical displacement, vertical velocity, vertical acceleration, all are 0. See the second case, there are two bodies are connected with the help of an inextensible string. So in this case, if we are applying the force, the body A will move, indirectly B also will move. So I can tell that SA and SB, displacement of A, that should be equal to displacement of B. Velocity of A is equal to velocity of B. Even acceleration of A is equal to acceleration of B. Okay, clear? Because these two are connected with an inextensible string. Now see the next case. In this case also, you can tell that if you apply the force from here, the body A as well as the body B will move. So this is the case in which the body in contact with each other. So SA and SB are equal, VA and VB are equal, A and AB are equal. Clear? Then next case is two bodies are placed on two inclined surfaces. In this case, you can understand that if this body weight is more, this body will come down and indirectly this body will go up. So it means that displacement of A is opposite to displacement of B. And the velocity of A and velocity of B, they may be equal but oppositely directed. Acceleration also like this, because one displacement is going up means another one is coming down. This case is a very important case. We have a body placed on a wedge and the body got slightly displaced so that the wedge is moving back. That's what I shown the dotted line. So what is the meaning? We have a body and the body is moving, body is sliding a little down so that the wedge is moving back. So they may ask, what is the displacement? So here I just marked it like this. We are just indicating the direction of this as x dash and this as y dash. And this direction as x and this direction as y. So when the body is moving down, this wedge is moving back. So this is the displacement. Okay, this is one displacement. At the same time, this you see with respect to the body was here, from there the body reached here. So what is the displacement? So I can find this displacement dE. dE means I shown that is y dash. So dE I can write it as OE sine theta, because we are just making a right angle triangle with the position of the block. Okay, the position of the block without movement, it should be here, but it moved here. With that I made a right triangle. So I made DE is equal to OE sine theta. DE means I told you it is in this direction y dash. And OE is nothing but I mark this is x direction. So x sine theta. If you want velocity and acceleration, you can find a similar method. For the velocity direction, we can write it as Vx sine theta. If you need the block acceleration, we can find Ay dash is equal to Ax sine theta. In this form, we can find the velocity and acceleration. So these are about constrained motion. Two more cases I want to discuss. That is, see the case in which a ring, that is, this is the ring. A ring is sliding over a smooth rod. So the ring is connected with the help of this block with the help of a string. Length of the string is L, but it is inclined like this. So in this case, you have to remember this one. What is the meaning means, you see, I know the total length is L, but the ring and this block displacement are in different direction. So what I am doing is, I can make a right triangle like this. So this is the hypotenuse. So I can write base square plus altitude square is this distance plus x. So we wrote L equals root over d square plus y square plus x. In many questions you should have this idea how to find out the length, because if the body is moving, okay, by pulling or pushing the body is moving, the length of the string cannot change. So that should be constant. That is our idea. So L is equal to root over d square plus y square plus x. Then in this case, what is the change in the x? That is called the velocity of the block. What is the change in the y? That is nothing but the velocity of the ring. So I can write dy by dt as velocity of ring, dx by dt as velocity of mass. Sometimes they will give the angle. They will ask what will be the angle here. So you can use the trigonometric ratio. What is cos theta? Adjacent side by hypotenuse. That is cos theta is equal to y by root over d square plus y square. So in this case also we can tell that if the ring is going up, this will go down. So in that way it will be a minus sign. The velocity of the mass is opposite to velocity of the ring of cos theta. Why cos theta? Because they are not in the straight line. So in this way we have to find out the relation. You have to draw the free body diagram and we should make the relation. I'll show on another case also. Here I told only one string. But here you see this string, they stretched like this, like an M shape it is. Okay, right? So in this case, at equilibrium condition, we makes an angle here, theta with vertical, this also theta with vertical. So in this case, I know the total length of this string is L. How can I find the L? I can take this hypotenuse, they both are equal because this is D, this is D. So we can take that 2 into root over d square plus y square. Why you people understood I feel? Because this is y, this is d. This will be root over d square plus y square. This also will be root over d square plus y square. So the length, adding these two. So 2 root over d square plus y square plus this length will be L. Here also we can find what is dy by dt. If you want the first body, you take dy by dt. If you want for this body speed, you take dx by dt. In this way we can find the velocity. So they are writing the second body velocity is equal to minus of 2 times of velocity of the first body into cos theta. Cos theta, why it is finding? Because of this angle. So this type of questions I have seen in many exams. You should get this idea. Okay, it's not like we are learning this. We are learning this type of equation. You should get the idea how to resolve this type of question. So how I did, I have taken the idea in which the length is constant. First you write a relation for length. After that you just find out if this block is moving, we know that this x is changing. So that will be its speed. Here also this block is moving, indirectly this quantity will vary. So that will be its speed. That idea should be there. Now this is a special case. Okay, in the previous video I gave quick revision for motion in a plane. There I gave the equation for range, height, time of flight and all. But this is the case, same case, but this projectile we are projecting from an inclined plane. So I am projecting a body in an inclined plane at an angle of alpha with respect to the base, and this inclined plane at an angle of beta. So with respect to the velocity, initial velocity, inclined plane makes an angle of alpha, inclined plane angle is beta. Time of flight equation is only important equation I am telling. 2u sine alpha minus beta by g cos beta is the equation for time of flight. And range equation, which one is easy for you that you can remember. These two equations, if you can remember, it will be better. 2u square sine alpha minus beta cos alpha by g cos square beta. This is the equation for range of the body when a projectile is projecting from an inclined plane of angle beta. Okay, this equation is nothing but trigonometric addition we are doing, or we are just make same thing, only we are arranging and writing. This one we are applying a trigonometric condition and writing. Okay, u square g cos square beta into sine 2 alpha minus beta minus sine beta. Here mostly I have seen the questions related with this. They will ask when we get the maximum range. We get the range as maximum for the condition alpha equals pi by 4 plus beta by 2. We are applying the condition here. When this value become maximum, we will check it. So we can write that alpha equals pi by 4 plus beta by 2. With that substitution, you will get an equation here. R max is equal to u square by g cos square beta into 1 minus sin beta. Learn this equation. In this equation, there is no alpha because we are substituting the alpha value like this. So, you have to remember this equation also. What is the range maximum? U square by g cos square beta. You can just make some similarity. Okay, I remember like this term is common in these two. Okay, then inside term only getting changed. Inside term also, you know, this will be 1 minus sin beta. This term only we are equating and finding. Okay, so we can find that value like that. It will be easy. Next, range maximum, you got it right. Now I am going for some numericals in this chapter. Okay, most of the important types. In the following figure, the pulley P1 is fixed and the pulley P2 is movable. If the weight W1 equals W2 equal 100 Newton, what is the angle AP2 P1? These are the two pulleys. This pulley is fixed, but this pulley is movable. Okay, here one weight is there, here one weight is there, but both the weight are 100 Newton. So they are telling like they makes an angle. I need to find this angle. Okay. So we are just taking, for finding the angle condition, I am just taking at equilibrium condition what happens. So I know the weight is same. So I am just redrawing the diagram here because with respect to this point, I can call the tension will be acting in these two direction. So I mark first the tensions. Okay. So see here, first we mark the tensions here. So this will be T. This also will be T. Then other than that, we know that here weight will be there, that is W2. So that only we wrote it here. And one more thing, this same tension only acting here also. As this is T, this weight is W1. So I am getting a very important idea from this diagram that W1 and tension should be same. Right? W1 and tension should be same. And this tension, this same tension only this and this because same wire. So I can draw it like this. This part is only here. Only this V-shaped thing. So this will be T. This also will be T. And this T is our W1 I found. Okay. T is nothing but W1. I have written here T is nothing but W1. So W1, W1. That is getting balanced with the weight. Weight is W2. Now, you know that in this case, there is no opposite component for your W2. So, we are resolving this W1 into two components. Which are they? W1 cos theta. Here I can write two components. One is W1 cos theta, W1 sin theta. This W1 also W1 cos theta, W1 sin theta. If you see the diagram, the sin thetas are oppositely directed. They get cancelled. Only cos theta remaining. So this W2 is balanced with this opposite component. Opposite component, two people are there. Which are they? One is due to this side, one is due to this side. That's the reason I have written 2W1 cos theta equals W2. That is 2 into 100 into cos theta is W2 is 100. That is cos theta equal 1 by 2, theta equal 60 degree. But we know the total angle they asked. They asked the total angle. Total angle is nothing but 2 theta, that is 120 degree. Clear? What we are doing? As it is the same string, the tension at this point and this weight should be equal. From there only we are getting the idea. Then I am just doing that too here. I did it there. Then this tension I am resolving it into two components, T sin theta, T cos theta, or W1 sin theta, W1 cos theta. I understood that sin thetas are cancelled, cos theta gets added. Clear? Now, see the next question. This is the first question. Then next question. Two pulleys and string are of negligible mass. For the system to remain in equilibrium, what should be theta? See, this is the diagram. Here one block, here one block, here one block. So I told equilibrium means we have to equate it. So what I am doing, this mass m, mass m. So weights are equal, no need to worry. So as it is same like previous one, the same wire only, so tension remains same. So I can write here this T and M are equal. T and M are equal. So I can write here this T, resolve it into two components. Same previous question. This will be T cos theta in two directions. T cos theta due to this T cos theta to this T. So total how many T will be there? 2T cos theta. That is balanced with your weight. There are components like this and this, but we don't consider because they get cancelled. So we can write at equilibrium 2T cos theta, that should be equal to root 2 mg. Root 2 mg. Then we already found T is equal to m. Okay. So we will write cos theta is equal to, what will be cos theta? T is equal to mg. So we can write here also mg. So mg get cancelled, mg and t get cancelled. So cos theta is equal to 1 by root 2, theta equal to 45. From this only we are writing T is nothing but weight of the body. What is weight of the body? Mg. What is weight of the body? Mg. What is weight of the body? Mg. So here it will be mg, root 2 mg, mg. I hope you understood this. This was similar type of question, but little extension. Here also we are applying the same condition, only same string, same wire, same tension we are doing and resolving tension into components. Now, another question. A mass M is hung by light inextensible string. The tension in the horizontal part. Here you see they gave a string like this. Okay. And here one mass they attached. Okay, here one mass they attached. Now, here in the question, as a mass is attached, this length of the string are not same. So, I cannot take the tensions are same here. Okay. So, what I am doing here, this tension is T2 I marked, this tension T1 I marked. They did not give it in the question, we marked. Then, this 30 they gave it in the question. So, with respect to this tension, I can resolve this into two components, which are they? This side will be T2 cos 30 and this side will be T2 sin 30. Now, by seeing the diagram, I understood that T2 cos theta is opposite to T1. That is our first equation. T2 cos theta is equal to T1. That is T2 into cos 30 is root 3 by 2. That is T2 2 by root 3 T1. This is your first equation. Okay. Now, we are equating this horizontal component, vertical component. Horizontal we equated. This we equated horizontal components. This I am equating vertical components. So, vertical components means T sin theta is balanced with mg. So, mg equals T2 sin 30. That is T2 by 2. That is mg into 2 by root 3. Because T2 you already got from here as 2 by root 3 T1 by 2. So, I got T1 as root 3 mg. Clear? So, you see I am showing a question in which tension is different. In this case, tension T1, right? Why we are resolving this? Because this is not along x-axis and y-axis. So, we found its x-axis and y-axis component. This we need not resolve because it is lying along x-axis only T1. Now, next also simple question. Two masses rest on a smooth surface as shown in the figure. Force exerted by P on Q is this type of question, contact forces. First you find out what should be the total acceleration of the system. That is A is equal to F1 by M1 plus M2. So 3 by 2 plus 1, that is 1 meter per second square. If they are asking the force exerted by P on Q means, you have to see P on Q means, how we are doing is, what is the force in which Q acts on P? That is 1 into 1. 1 into 1 is 1 Newton. Force exerted by, that is nothing but the contact forces. Why I am taken like this? We have to see, this will give a force here, that will give an indirectly reverse force. That should be equal and opposite. So here what is the mass? 1 kg. So you have to take that only. So 1 into 1 is the action force and the reaction force also same. That will be 1 Newton. Now, an inclined plane makes an angle 30 degree with the horizontal. A groove OA of length 5 meter cut in the plane makes an angle 30 degree with OX. A short smooth cylinder is free to slide down under gravity. The time taken by the cylinder to reach from A to O. Here there is a groove. From the groove a cylinder is coming down. What is the time taken? This is inclined plane ka inclination. plane itself inclined. So I discussed in the previous video, for an inclined plane, what is your acceleration? A is equal to g sine 30 or g sine theta. Okay, in this case, that is for the body moving like this. But this one, the body is moving along, again an inclined thing. So this I can take it as A1. So if A2 is equal to, so Siri, this is equal to A1. So A2 I can take it as A1 of sine theta. Why we are doing that? Because this, what is the first one? That is for the inclined plane. Now this is the body rolling in an inclined plane. Again it is inclined at an angle of 30 degree. So I can take here, acceleration is g sine 30 into sine 30. That is 10 into 1 by 2 into 1 by 2. That is 2.5 meter per second square. Time, if you want, you know it's simple. S is equal to half gt square or half at square. So t is equal to root over 2s by a. 2 into s, they gave it in the question 5 meter, by acceleration is 2.5. Here only one thing, why I picked this question, because of this equation. Okay, acceleration of cylinder down in a plane. Here the problem, if it is only inclined plane. Okay, see this one is not there. A cylinder we place here, cylinder is coming down, g sine theta only. But this is cylinder is coming to a groove which is inclined, again an angle of this. Next. In this question, A and B are beads A and B, each of mass m, are connected by a light inextensible cord. They are constrained to move on a frictionless ring in a vertical plane. The beads are released from rest at a position shown. The tension in the cord just after the release. So this is your ring. This two are beads. Okay, these are connected with a string. So when it is releasing, what's the tension just after the release, they ask. So I drawn the free body diagram. For this block, there will be a normal reaction and it tries to come in this direction because your weight is more. So I can take it here because it has a tendency to move it like this. AA. For the body B, the weight will be mg and it has a tendency to come down. This is also mg. And you know that this is nothing but the radius, this is also nothing but radius. So it is an isosceles right triangle, so this angle will be 45 degree. Then if you take with this sine 45, this is the adjacent side and this part is the opposite side, right? If you see, this part is the opposite side, I can mark it now. I am just doing it. This tension I am resolving it into two components, means this is nothing but T sine 45. So that is the reason I have written this equation. mg is down but still body is coming down, means mg is greater than T sine 45. So I wrote mg minus T sine 45 is ma. That is nothing but the acceleration of the body B. But if you take for this one, this is your tension. This also 45 degree. So I can take a pseudo force in the opposite direction, so that I can write here also T sine 45 is equal to ma. T sine 45 is equal to ma. Then these two equations, this is the first equation, T sine 45, how we are getting this one, this body, right? This is the tension of this bead, this is the tension of this bead. So this tension, when we are resolving it into two components, I am getting two things. So here I am taking a pseudo force which is going in the opposite direction. So I can write T sine 45 is ma, mg minus T sine 45 is ma. This is for the first body, this is for the second body. Both are ma we wrote because both are of same mass. After this, you subtract from this equation to this. So I can write 2T sine 45 is equal to mg. 2T sine 45 is equal to mg. So mg by 2 into 1 by root 2. That is mg by root 2 is your answer. Nothing I did, only resolving. Remember these two blocks, how we are resolving? This tension we are resolving like this and this. Okay. So this is balanced with your mg I did. Then I am taking for this bead. This bead tension will be like this. That also we are resolving into two components. From that we are getting. Now, This is a very simple question. A block of mass 2 kg moving towards east with a uniform speed of 2 meter per second. A force of 3 Newton is applied to it towards the north. The magnitude of displacement after displacement of the body 2 seconds after the application of force. We have the north, we have the east. Okay. So remember, east means I can mark it as I. North means I can mark the unit vector J. So what they did, you see, they gave the body of mass 2 kg. So I wrote m equal 2 kg. Force is towards north, so we wrote 3j. So what is acceleration? F by m, that is 3 by 2j. What is s? S equals ut plus half at square. U, what is your u? 2. 2 into, after which time they are asking? 2 seconds. 2 into 2 plus half into 3 by 2 into t square. 4i plus 3j, that is your displacement. After that, the displacement s is equal to root over 4 square plus 3 square. That is root over 16 plus 9, root over 25, that is equal to 5 meter. Understood? Simple question. Only one thing, they gave force. So you have to remember like this. East and west means you don't simply take it. You have to mark with the direction. So force is towards north. So I wrote 3j. So acceleration also towards j only. So the displacement I am getting both x-axis and y-axis. See the next question. A 40 kg slab rests on a frictionless floor as shown in the figure. A 10 kg block rests on the top of a slab. So like this, 40 kg, 10 kg. The static friction is 0.60 and the kinetic friction is 0.40. 10 kg block is acted by a force of 100 Newton. What is the acceleration? So this is a smooth surface, but here some friction is there. So first itself we have to find out what should be the frictional force between 10 kg and 40 kg. I am doing the maximum friction, that is the maximum static friction is called the limiting friction, that is mu s mag, because the other day I gave you equation F is equal to mu n, that is nothing but mu into mg. So mu into m into g, 60 Newton I got. But here the applied force is 100. Now I understood my applied force is greater than frictional force. So definitely body moves. So I can write, so the block will slip over the slab. So what is your kinetic friction? Kinetic friction I can write it as mu k ma into g. Mu k ma into g. So kinetic friction value they gave 0.40 into 10 into 10, that is 40 Newton. Now I need to find with that 40 Newton only, because there is no force for your B. From where B is getting the force? B is getting the resultant force on A. We are giving 100, but frictional force is there, 60 frictional force only. Remaining 40 they are getting. That 40 Newton only getting for our B. So acceleration of body B is 40 by mass of B. 40 by 40, that is 1 meter per second square. Understood? This type of questions also important for the exam. So what is the question here? 40 kg on a smooth surface, but 10 kg is not on a smooth surface, it's on a rough surface. Then they are asking what is the acceleration of B. Directly for B there is no force, but A is getting the force. Then out of that force, total force A is not getting because friction is there. So we should find out what is the net force acting. Net force I am getting as 40 Newton, that I found with the kinetic friction only. With that friction only we are getting. There are few questions it will come. Just take the reverse case. I am getting the friction as 100 and applied force as 60. So in that case the body won't move. What is the case? If frictional force is greater than applied force, body does not move. Body does not move. Sometimes questions will come like that. So it's very important in a question you have to check first what should be the friction. Okay, so in this case the friction is lesser than your applied force, so the body moves. So your body moves. Clear? Next. Next question. 3 identical rigid circular cylinders A, B, C are arranged on a smooth inclined surface. That means this is the given diagram. This is the first diagram they gave. These are three cylinders A, B and the top is C, and they are placed on an inclined surface of angle theta. They are asking what should be the value of theta so that it should not collapse. From that, I have taken two bodies separately. So I have taken the second diagram. This second diagram means I have taken the top body. This is the top body C. In the top body, we know that vertically down there will be weight W. Other than that, there will be a normal reaction of A and B acting in this direction. That are these two, N1, N1. They are identical. So you can write N1, N1. So N1 and N1 makes we get an angle there. Right? Then after that, they are given here. This one, we are just taking here, the weight of the body will be there, the W. Then, this you see, there is one block here, okay? Here there is a block, this A. If you take A, you have to take the weight of the A, that is W. Other than that, we know that there is a normal reaction will be there. Normal reaction, the two ways they are marking, one is perpendicularly up. Other than that, see, there are two normal reactions I marked. N2 I marked, that is normal reaction between A and the inclined plane. And N1 is the normal reaction between A and C, B and C. That is these two I marked. Other than that, N2 is there. What is the direction of N2? N2 means with respect to this inclined surface, we get a force. So with respect to inclined surface also we are getting. With respect to inclined surface also we are getting. So in this case we have this N2. N2 is with respect to A and inclined plane, and N1 is with respect to the bodies. Okay. Now what I am doing is only for the C. See how we are getting 60. We get this form like an equilateral triangle because all are right. All are identical cylinders. So when we place it like this, their distances will be same. So the angle will come as 60 degree. So the half will be 30 and 30. Right. So I am just resolving this into two components from the diagram. That is N1. We are resolving it into two components. Which are they? N1 cos and N1 sin. This N also, if you are just extending it back, we get two components. So we understood that opposite components are sine get cancelled. We get only cos. 2N1 cos 30 equals W. That is, we know cos 30 is cos 30 is root 3 by 2. 2 get cancelled. So N1 is equal to W by root 3. When the arrangement is on the point of collapsing, the reaction of A and B is 0. This is a very important point you remember. If it is collapsing, A and B reaction force will be 0. Now I am taken from this diagram. From this diagram N1 we marked, N2 also we marked. N2 is with respect to the plane I told. Here also we can resolve it into two components here, but we don't know what is the angle this theta. So this N2 when you are resolving also we get two components, one in the horizontal direction, other one in the vertical direction. This also we will get in the horizontal direction, we get it in the vertical direction. Right? So we will write N2 sin 30 is equal to N1 sin 30. Okay? N1 sin 30 means which component? This one. This is N1 sin 30. The opposite component, this will be there. So we can tell that these two we can equate it. N2 sin 30 is equal to N1 sin theta is equal to, see here, we are taken for the body A. For the body A, we have two normal reaction. One is N1, other one is N2. N2 we are resolving into sin theta and cos theta. So N2 sin theta should be equal to N1 sin 30. That is N2 sin theta is equal to W by 2 by root 3 because we are substituting this value. But when we are taking the cos component is the adjacent component we know. When you take the cos component, we have W1 We have n1 cos 30 also. N1 cos 30 also you have to consider. This diagram they are extending little down and they are doing it. Right. So we have how many components will be there? Cos component will come here. N2 cos theta is there. W1 plus n1 cos 30. These all we need to add in. So it means that we are equating sine components as well as cos component. We are equating sine component as well as cos component. In this case, see this angle I mark here as theta. Don't get confused. This is theta. So this is your cos component. Okay, this will be your n2 cos theta. So remember those. And this will be n1 n2 cos component will come here, and see you have to see with the directions only. When we are taking the direction, it will go up and it will go up. So one component in the opposite direction. You have to mark this n2 like this, n2 into cos theta. Okay, because n2 they gave it like this. N2 they gave it like this means how we will resolve. One component will be like this, that is n2 cos theta. That's what I put up arrow mark. This will be n2 sin theta. Now I think you got clear. I just resolved this one. N1 anyway they are given. N1 we know that n1 cos component will be there, n1 sin component will be there. So we can just write it here. N2 cos theta is equal to n2 cos theta is equal to w1 plus n1 cos 30. That is 3w by 2. So if you are dividing this equation with this equation, tan theta is 1 by 3 root 3 or tan inverse 1 by 3 root 3. So this question, it's little challenging question. First thing you have to understand that how to resolve it. I have taken two bodies separately. First top body, that is very simple. Top body, what are the normal reaction? Weight and normal reaction. That's we equated very fast. This will be, we understood that it will go up, cos component will be there. This both this cos component and sine component we did. Okay, this is vertically opposite angle. So we can take this will be there. This n2 cos will come in this direction only. So that too we did. The same thing we are doing for this case also for the block A. This is for the block C. Then you take for the block A or the cylinder A. Cylinder A, two normal reactions are there. One we are resolving in terms of theta. Other one we are resolving in terms of 30. So in that one I showed you how we are doing N2 we are resolving it as N2 cos theta and N2 sin theta we are taking. Therefore, we understood that N2 cos theta and W1 are oppositely directed. That is only one idea you should have. So this equation I got it. And this is your opposite horizontal components. In this case, horizontal components will come as N2 sin theta is equal to N1 sin 30. We are equating those and we are getting. So these type of questions you have to practice from this chapter. Thank you and subscribe for V Guide to get more videos. Thank you.